Hello. 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 Am I audible?
Yes, sir. Yes, sir. Good evening, sir. Welcome, sir.
Am I audible? Yes, yes. Good evening.
Yes, sir. Welcome, sir. Good evening, sir.
Good evening. Good evening. Okay. Now I'm going to share my screen to all of you for this last session. Okay. My screen is visible. My screen is visible. Hello. Hello.
Yes, sir. It is
Uh,
visible.
uh, Now this class is also live on the YouTube, and I have shared the link, so you can ask any question through live chat or here. So today is the analysis for the raster data analysis, how we can analyze the raster data in R. So I'm going to explain some codes, then we will do something on the operation on R platform. And I have already shared the explanation code and one data, that is a l.tiff. That is a tiff is a raster data. So the first, what will you do? You have to make a folder. That folder name is the SHP. you can name any name, but here I gave the name SHP and save in your laptop or PC at any location. So I have saved my folder, that created folder on desktop, so the its path for my PC is this. On for setting the working directory, use the code setwd. This sets the working directory where your files are shared. In this case, it points to a folder on the desktop called SHP where the necessary files like raster data and C files are located. So for this raster data analysis, we require some libraries, some packages. So the packages are the raster, ggplot2 and patchwork. What this will, why we are doing this? The first is raster. This library is used to work with raster data, grid data like satellite imagery, climate data. This will deal with the raster packages. And ggplot2, a popular library for creating high quality plots and visualization in R. Patchwork, a library that helps combine multiple plots in a single layout. And how to activate this library with the syntax? Write the library. Library is a code for to activating your packages. And how to download? We have already discussed. So load the last raster file, and this is basically a rainfall data, TRM rainfall data, and that's is a TRM is basically at 25 kilometer resolution, and this uh, is a satellite data that is stored in a raster format. So it's a type of the rainfall data. So I have a raster data, that's variable is a rainfall. So that name of this is l.tiff, which I have shared on the through WhatsApp. So call this and make a variable, for variable sign this one, and for calling any raster data use the raster function that will work under the your raster library. So explanation of this line of the code: the line loads a raster file, the name of the raster file l.tiff. If you are looking in your WhatsApp group, I have shared this file. From the specified location on your computer into R, the raster function is used to read and load raster data into the variable name. That's variable name. So the work of this raster function is read and load in your R environment from your desired working directory. So next line of the codes: extract raster values and remove any values. Any values with no values. First raster values, make a again a variable for your this one trm file, and here use the function values and raster values, raster underscore values. Here the sign, use the explanatory sign, use the explanatory sign. And is dot na is your use for to removing is dot explain with the sign operator, that is explanatory, and is dot na function for use for to removing na values in your raster file. If in starting, if you remember, remember, uh, there is some na values in the raster file. So we are not interested in this analysis for na values, so we have to remove this for removing na value, this function we will use. So explanation of this function is values trm rainfall. This extract the values of the raster, the pixel values, and the explanatory is dot na for your this variable. This removes any na values, missing data from the raster values, leave only valid data for the further analysis. So we are doing operation on the raster analysis. So we will do some statistical calculation here. I use only 5 type of the statistical, but you can use them more than 5. So for this, each we will make a this one variable for each statistical value. Suppose that we want to calculate the mean, so use the mean function. Here make a variable, that is the mean underscore bl. And for median, what is the mean, median, standard deviation, minimum, maximum? You know well. So these are the functions we will use for the statistical analysis. These lines calculate basic statistics for the raster data. Mean, the average of the all raster values. Median, the middle values of the raster values when stored. Standard deviation, a measure of how spread out the values are. Mean, the smallest values in the raster. Maximum, the largest values in the raster. So create a stylus. Now we will create a stylus raster plot using ggplot2. For again, make a variable raster underscore df in which we will make a data frame for raster data. Use the as function as dot data dot frame. Here again use as, and this is your variable that contain your raster file. And here write in frame, that is spatial pixel data frame, that is your this one, this is your string. It's top of the your plotting, this will visible. Columns name raster and underscore df c, and rainfall make it in a frame, and combined with the crs latitude and longitude, that is x and y. And you can rename the column if you want. Suppose that you want to change its header name of your plotting, so you can change. So this will more clear. strm underscore rainfall and double inverted spatial pixel data frame is this converts the raster data into a data frame where each pixel or cell in the raster becomes a row in the data frame. So columns raster underscore df and the variable c double rainfall and this one xy. This means the columns of the data frame to represent the rainfall values and their corresponding x and y coordinates, longitude and latitude. So raster plot, again use some function, raster plot ggplot raster df and concern this value of the rainfall. This will make a your bar scale and the value of the your rainfall, how these values are changing, and what is the meaning of this complex coding we will see here. So ggplot raster underscore df aes x is equal to x, y is equal to y, and field rainfall. What is the meaning of this? This create a plot using ggplot2 where x and y coordinates are used for the plot's axis, and the rainfall values determine the color fill of each tile. What is the tile and what is the pixel? What is the cell? We have discussed in the first class. So geom underscore tile. This function creates a grid of colored tiles to represent the raster data. Scale underscore fill underscore grade. This function gradient. This sets the color gradient to display the rainfall values using a palette of the colors, 10 colors from the terrain colors. Yeah, I'm using the terrain dot colors function. It is for the terrain color. What is the terrain color? Just go and Google search. Labs adds title and access levels to the plot. Theme underscore minimal applies a clean minimal theme to the plot. Theme customize the plot appearance, such as making the title bold and centered and positioning the legend. Core underscore fixed ratio is equal to 1. Ensure that the x and y axis have the same scale, so the plot has a fixed aspect ratio. So now next is to create a stylus histogram, because when we are doing some statistical analysis for this rainfall data, we will plot this raster plot in a special for a special information of the rainfall, and now we will do the some histogram plot for these rainfall data. So we will use the make for the variable that's name is the histogram plot, and of course this is the plotting result. Then we will use this ggplot2 and again make a data frame for the rainfall and raster values which contain aes is equal to x, and this is the complex coding. So I'm explaining the this code. ggplot2 data dot frame rainfall is equal to raster is equal to aes is equal to x is equal to rainfall creates a histogram using the raster values. So geom underscore histogram, this creates the histogram where the bin width if you read about the histogram, there is a bin width, the width of the histogram that we have to set. So here the function that is bin width, bin width we have defined uh, is calculated based on the range of values divided by 30 to determine the size of each bin. Labs as the title and access labels to the histogram. Theme underscore minimal applies a minimal theme for simplicity. Theme customize the plot's appearance, such as adjusting the size of the access text. So now combining all plot, that is your statistical value, histogram plot, and the raster plot on a single layout. So because statistical plot, what is the statistical plot? It's a text only. So for writing this text only, we'll use this code state underscore text plot and ggplot plus annotate text and what is the meaning of this we will see here. Ggplot, create a plot without any data. This will just contain text, uh, any type of the data. So it will be text or it will be image or it will be any type of the data. Annotate, what is the annotate? In bracket whatever you want to write text, x is equal to y is equal to 1, label paste, and this one as the calculate statistical statistics mean median value as text to the plot. So annotate, when we are converting our text into the plot, then use the annotate function. Round rounds the value of two decimal places. So here round is written here. Where is the round median here 2, it's 2. If you are writing 3, then it means up to the 3 decimal places. Theme underscore void removes all access label, grid lines, and other plots elements, leaving just the text. So now finally combine raster plot, histogram, and statistical test plot using patchwork. So if you remember in starting here, I am including a new package that name is the patchwork. And what is the work of the patchwork? A library that helps combine multiple plots into single layout. So here when combining, then use this make a variable, name it's a combined plot, raster plot, histogram plot, and this hyphen stats text plot, and finally write the print combined plot. Then you'll get the plot of for all. So explanation of this line of the code: raster underscore plot and underscore histogram underscore plot combine the raster plot and histogram vertically. One is the above and the other one is the side. You can change the when you can change its value. Suppose that you can put here histogram, you can put, then space of the your plotting is been changed, as it is up to you. So hyphen states underscore text dot plot, what is this for? Places the statistical text place to the right of the combined raster and histogram plots. So finally print combined plot display the final combined plot. So this process result in a neat layout that includes the three sections: a raster map of rainfall, distribution, a histogram of rainfall and value, and a text summary of the basic text. So we will do the practical on this. I have explained all these things. So why are you not opening the live streaming link? Because I cannot see the here any one is present here in the YouTube. I have already shared the link to on this. Okay, I'm again share the link in chat box. Okay, I have shared. So please go and some ask question here on a live chat box or like share. So now I'm going to the plotting. I have already shared the data with you, and here the raster analysis. I'm copy this data. Okay, now it has been done. Now the first things, what is the first thing? We have to set the our this one W working directory, and whether our directory is set for my desired folder or not. We will. Hello, am I audible? Hello, hello.
Yes, sir, audible.
Okay, okay, sure. For we will use the get WD function. Get WD. Okay. Now run this. Then when you are using the get WD function, then what will happen? You will find your path of your working directory. So activate this library, which I have already explained. That library is the raster, and that packages is the raster, ggplot2, and patchwork. So we activate through library function. I've already installed. If not installed, then just go to the package and go here and install and do. So next, I have already shared this l.tif file in through this one. That's WhatsApp group. Again, I'm sharing this file through chat box. Sorry, I cannot. Sorry, I cannot attach any file here. So anyway, I have shared this file too. So run this. So our TRM file has been attached to our this R Studio through my working directory SHP, where I have kept this file. Now check its raster information. The class of this is the raster layer. Dimension of this 14, 19 to say 14 is row column, 19 is a it's a number of column, and 266 is number of the cell value. That cell value is a nothing but a pixel value, and the resolution is 0.25, 0.25. It's in that is in this one degree. So WGS84 projection for this, not for the UTM projection. So do this. Now next is the make a this extract raster value and remove any values. For do this operation we have done. Now see, and these are the values of this, and after the removing the values, only the 109 this one, how many columns are there? 266 cells, but after removing any values, 109 values. So calculate the statistical value on these raster values which I have calculated. So this one, so mean of this value is 1 14 20.75 0.95 mm, and this is your median. Now this st value is this one, st value 2 to 6 point. St is a standard deviation, and now calculate the your this one minimum value and maximum value. So this one. Now one thing, when you will use the print function and for your this raster variable print here, then what will happen? See, this will x y and the same things will have come. Okay, so create a, now make a variable for creating a stylus plot and under the ggplot2 function. So if you want writing something other thing, then use this and so this now. See, this is your variable. Variable L is your rainfall, X is your X coordinate, Y is equal to Y coordinate, latitude and longitude. So rename the columns of this. So after renaming, what will happen? The L value is converted into your rainfall. So next is the use the raster plot for this, and this will it is not visible, but you will here. Okay, just give me 1 minute for this. Now we have run for this for this raster plot, but it's not a plotting result you will get. So what you will get the plotting result in the final. So see, when you will use this only the just select and run, then find that this is your the raster plot. But this is not our the final plot. We have to plot with this is the latitude, longitude, and this is your raster. So value of this, and this is a terrain color, that's I have explained. But this can plot with some histogram, some its statistical value, then this will be meaningful. And here the see the 1800 is the red color is the maximum rainfall, this area is the maximum rainfall, this area is the minimum rainfall. This is the way, this is the where place, this is the trm file for Jharkhand state. See, this is the Jharkhand state. So next is a create a stylus histogram plot. So creating histogram, again this is not showing here, but when we will select this and run, then this will appearing here. So here is a big gap between 1500 to 1700. Then what is this? This is basically showing your what is showing this way. This is basically showing your outlier value. And why outlier value? It means that it in some place the rainfall is very minimum, so that's why it is showing. So for checking the outlier where is not in outlier or inlier value, we will use the box plot. So use the box plot and use that rainfall, that is the this one raster values, and we are interested in rainfall. So it has already, see here the lots of the outlier value. Outlier means this is the box plot, and in box plot there is why box plot is a very good way for showing your statistical value, because this is showing six type of the statistical value in a single plot. This basically this is a box and mustache plot. This is the tell, and beyond this tell it is a minimum value in layer, and this is the minimum value, and this is the tell mustache, that is showing the maximum value, and beyond this is called the outlier. This value is the outlier value. That's why we are getting a huge gap between these value, because value suddenly change, not gradually, drastically the value change. So we will get the, and this is the analysis part. You can analyze through statistical and this raster value. So come to the this, and this value is your median value, and this is mean value. This is your interquartile region, first range, second range. So you can get the six type of statistical values through the box plot. So now create a statistical plot on this, and for this no need. When we will select and run this, then find this one, and this plot we will plot in a single layout. So here the mean is you have calculated standard deviation. If you want more, then calculate the more and just write here with the help of the comma and use, and up to the 2 decimal this is taken. If you are written here the 3, then it will calculate the up to the 3 decimal. Suppose that for mean value I am written here 3, then this will return for up to the 3 value if 3 values are given. So again I'm plotting. So for mean I have, it's mean that there is no 3 values in this. When I am written here 1, then it must be reduced for mean. See, before it's 9.5 for mean value. When I rounded it up to the only 1 decimal, then it's a 9. Why this is not figure taken for the 3? Because up to the 3 decimal is not exist in this data type when we have calculating the mean value. So combine a single plot in all plots combine in a single layout. So run this and use the print function. So this is the final result for your statistical analysis. So this is the way for raster and data analysis through a GIS platform, that's R. So if you want to export this, use this function and whatever extension you need, chip, TFG and whatever. Suppose that I'm TIFF, suppose that I'm meta file. That's a very good resolution, enhance meta format. Just increase this one. Okay, I'm increasing its size and save. I give its name day 5 because today is the day 5 for this class. So it has been plotted in our desired folder. That folder name is SHP. Mm, Today is .amf, and this will directly open through Paint. See, cut it because this is so gaps are showing here. Make this one and crop. So see, all things are visible and you can use in your research paper and things and explain everything in a single layout. Okay, now next important things which is very important. I'm going to publish this as a HTML file. Suppose that someone want to see your plot, but you cannot send this plot, only want to send the link. So go to the this publish plot and just click on the publish. So I want to publish as a rpubs. So publish. So description of this day 5. Okay, and plot is it. You have to make this one through, and now I'm share this thing to on chat box and just open it, and this will find the plot of this. Just open it. I'm just sending this. Okay, uh, just click on this and see, you are able to visible the all plot through the HTML link. So how to publish your data as a HTML through rpubs you have learned. So if you want delete, then just click on delete if plotting result and this are given. So if you want delete this your data, so you can delete it, but you have to make a this profile for our purpose. So if you have any question on this topic, please ask. Hello, if you have any question on this topic, please ask.
Excuse me, sir.
Yes.
This you have made this plot now only for Jharkhand. In case if I want to make for any other place, then
Mm-hmm.
in the syntax where I have to change.
Yes, no change to in the syntax. Only just go where is the R. This one. Suppose that you have any other file. Just make a TIFF file here. Its extension is a TIFF. If R img, then .img is also a raster format. TIFF is also a raster format. So suppose that your file name is a that's kept in your folder, that is working directory folder SHP. Just keep, and suppose that your name is XYZ. Your file name is XYZ. Just keep it name XYZ. Then directly this connect to the your through raster function in your R environment. So anyone have other question? Just do for your data set. I will
Sir,
in yes.
excuse me, sir. Here this LTA file already you got it now.
LT, where
For
is the LT? Where is the LT?
here already you put SHP double slash LL
L dot
dot.
tiff. Tiff format is for what? Tiff format is for the raster data format. Dot
Okay, sir.
img data format, and that's I have explained in very first class. Please go through my PPT of the first class. Then you will find this. I have
In
explained in a
case
detailed way what is the raster file and what is the vector file. I have explained everything in a detailed way. Yes.
if you want to do for the Balia district, can you do it, sir? On demo.
Yes, Balia district is a what? That's is your save file. That is the vector file. Here the topic
Hmm.
is the raster analysis. If you have a data for the Balia district, then I will do for the Balia district. But sir, presently I have no data for the TIFF file of the any Balia districts. I just extract the file for the for presenting here. State that selecting the your Jharkhand state. Just go through
Okay,
the
that is my question, sir. Actually, for Jharkhand already we have this data. We are
hmm.
just inputting like in case
Yes.
if we want any other place, how we can get it, sir?
If you have another place, suppose that if you have a data for the another, first you have to must be have to data. Okay.
Hmm.
Second,
Hmm.
how this data connect to the R studio. Then you have to activate these things. The first you have to set your working directory for your desired folder where the data has been kept by you. That data in name is suppose that XYZ, and XYZ is kept in that folder. That name is the SSP. So your R studio is containing connecting your R folder with the help of this. Okay. Now activate this library, and what the work of this library I have already explained. Next things you have to calling your data set. For calling your data set you have to make a variable. I am making the variable that because of my rainfall data, then I am making the this one, and use the function raster, and write here the path for our this data set, and write here the these things. Okay. And the SSP LTF, but you have already connect your folder this, and then no need to write the path of this. Only write you have to this one, then this will work. This again I'm saying just to remove this one because you have already set your working directory. Then in working directory this will search for the your data set. My data set l.tf, suppose that your data set xyz. Then this will search, and this will definitely will work. See here the this will work. Okay, I am run this, and again this one. See, so must this will be explained through the your path, your working directory folder, and your data name, and the function that you are using, and the packages that activate environment and in your R studio for doing this type of the analysis. Have you any question related to this? Otherwise I will go move for further something. Hello. Hello.
ಅದ್ ನಮ್ದಲ್ಲ.
Yes. Okay. Now I'm going to the next things. The next is that I'm going to the that folder. Hmm. One thing which is living, that name is your this one, and that is say point regression raster analysis. How it has been done. Raster image stacking. How we will do for the image stacking. So this I am sharing this code to the all of you. For image stacking, we are using some raster file. So go to my desktop and working directory folder, that is SSP folder, and here the image stacking file. So these are the raster file. I just copy this one and paste here, and also copy one by one. Please install and keep in your data in your this one working directory folder. So activate this library. I have already explained in detail all library, and I have already shared this library to all of you. No need to this one. Either map tools. If map tools has been working in this version, then we will do for this. No, for this version map tool is not. Don't worry, this will work. So no need to this because I have already set up this file with this. So anyway, we will do for this. Set the path, make it double for connecting folder. Now my folder is this one. Now for image stacking, use the function file dot path. And what is the image stacking? I just explaining that what is the image stacking. So suppose that this is your first raster data A. This is your the second raster data B. And this is your the uh, third raster data C. And this is your fourth raster data say D. Suppose that D. So I want to add all this data in a single data frame. That is called the image stacking. When we will stack this one, then this will may construct like this. Okay, in a single data frame. Okay, I want to this, and this is a very important operation in GIS and remote sensing. So how we will do through this platform? We'll see here. So first define the path where my folder is containing all raster files. Here the .shp file is for your this save file, and this one. So and the extension of your raster file is a tiff file. So do this. So see when we'll run this. C user 1, 2, 3, 4, 5, 2, 3, 4, 6 GH, and these are the raster file. And now we will stack with the help of the raster double column raster stack function. And now it is administrated. Now stack function my stack come to the with the help of stack and use make it the name variable sg. Now what is the sg? When we will run sg and see here, it's come under a single data frame where the names x1, x2, x3, x4, x5, x7, gh, rain, k, l, these are the raster file name. And how many these files are? There are 10 files. 10 files and 10 layers. That is the raster layer, which and the one thing is very important that uh, all projection must be same, column and row value must be same, then this image operation will be done, otherwise not. So give some name of this when we are going to plot. So when you'll use the function windows, then this will open a new type of R graphics, and this is a very powerful graphic for the visualizing image values. So now level plots, we will do level plots and use this and polygon as we have already defined here the in the starting. It is showing the some warning message in the pro.prg file is not containing my save file, but it's okay, this will work. Error in label plot, extra sg margin color. So just copy this one, and we will not do this for okay, we will do for this and suppose that shp file here, Jharkhand save file, copy all file and shp, and here paste, refresh file at destination and again run, then see what will happen. Mm, again there is some problem in shp Jharkhand output.shp. What is the problem? ZADL error. Okay, anyway, just leave it and just copy this one and here and paste and remove this polygon part. Now run this. Oh, there is some problem. I think there is some problem in this one. Anyway, up to the 6, I'm again making some files here. Gives Control V, that's diff file, and give its name shp1. Okay, now I'm going to update according to that one. Let's remove this one. That's name is the shp1. So keep the file name, that file Jharkhand, where is the shp. Okay, now the name is the shp1. Again it is showing some error. Anyway, don't worry. Yes. Hello. Yes, there is a tool that's name is this GIS tools, and it is important for this one learning required because now its GIS tool has been connected. Now I have to check this one again because if any library is not working, then you will be problem because level plot work under the GIS tool. So that's why level plot function is not showing here. Now GIS tool isn't working. Map tools, okay. Map tool is I think not required, but if required, then we will do for this because it is not compatible with 4.3. It's for higher version. Mm, if not, then we will not do map. Okay, it is not there. Don't worry. And it is online available or not? We will check this one. Map tools. No, it is not there. So don't worry. This will work with this. Need help? Try Stack Overflow. STP Stack Overflow. ggplot2. One ggplot2 was built under. Okay, this will work. Uh, if you are new, and please install the 4.3.3 version because it is old and most of the packages were not compatible with this, but this will work in 4.3.2.
Sir, excuse me, sir. Now it is 4.4.2, sir. That version I got, sir. 4.4.2.
So that is the higher version now. 4.4 is higher than 4.3, so it will work.
Hmm.
That's the higher version. So just take the higher version of this because most of the this suppose that map tools is not available online. But at that time when I'm installing this 4.3.2 1 year ago, then this will work. But this is not working because all and neither offline nor online is this tools is available. So next do same things for all. Let's see what happened. See, this is the image stacking. This is raster 1, raster 2, raster 3, raster 4, and this is for the rainfall data. And here the save file is not added because some files information are missing. When I'm going to here, the save warning we had .prg because there when you see in a save file there are 6 type of the and .prg for your geometry type. So warning messages are come here. Okay, I will check whether this will work or not. Oh, this is work. Nice. The C, this is work, and the C file also added in this, and this is for the 1, 2, 3, 4, and this way. This is the stack image raster images, and as for all raster data, use a single this one. That's name is
Sir, excuse me, sir.
yes,
Excuse me, sir. This is the maximum resolution of the image, sir.
yes. This is the maximum. Okay, if you want to take the resolution, just go and file here and set jpg image and 100% quality. So this is the maximum reservation, but nowadays some packages are come for just suppose that ggplot to work under very high resolution. So search on internet this will for high resolution or not. So do for this, and definitely you will find, and you will get the more better resolution than this. Or you cannot say that this is a higher resolution under shiny environment. Here the shiny environment is the r shiny. Just see here, where is this text file shiny web app. This will be very work under for very high resolution environment leaflet, and this will be work. Okay, hello. If you have any question, please ask. And now questions and answer hours has been started. And before this
Excuse
session,
me, sir.
yes,
For
yes.
this image, that's for the last one. This syntax we did not get, sir. Only for raster file you posted in the WhatsApp. But this one, the command and all, I think we didn't get it.
Yes, I have even just I have pasted this one. Again, I am going to paste this code to into the chat box. Please see. Uh, please see. I am again sending this. R code has I have already sent this.
Sir, please delete the old.
Yes.
Please delete the old code so that we can take the new one. Otherwise, hello, sir. Confusing.
The latest one is this one for the okay. Don't worry, I will share all code in a file and written here, and already written here the things. Yes, for which code is used for the which code. Suppose that here written the image stacking. Hello.
Hello. Hello, sir.
Yes,
Hello, sir. Yes.
yes,
Am I
yes,
audible? Yes.
yes. You are audible.
Sir, I have. Yes. I have one question. Question means how to download rainfall data
Hmm.
for district level. Could
Yes,
you please show it through R if necessary in the next session?
yes. If you want to download the our rainfall data.
Rainfall and temperature data.
Yes, yes.
Yes.
Then
Rainfall
suppose
and
that
temperature data in
you
district
want
level.
to download TRM rainfall data. Then where is this will be? We will see tropical rainfall mission. So open this one, and then you have to make a account this one. And this account is a credential for your this website. So in URL, suppose that in my previous code which I have shared for downloading in this one point proximity analysis, buffer analysis, which I have directly downloaded this data. But this data you cannot directly download it, because when you go to the data directory, then this will ask for your account. It must be account is there, because it's a nasa.gov. You have to make account. Then you have to give the credential for this id and password in url. So you have to give this one, then this will work. Okay. And do for this, if you have any problem, then please ask.
Okay.
Yes. Have anyone other question, please ask. So first we have read about the details of the GIS. What is the GIS? And read about the data type. What is the raster? What is the cell? What is the bit depth? What is the this one vector? And after then understanding, we will understand the coordinate reference information, reference system. What is the data frame? And how to construct a data frame in the R environment. We have seen the projection, how many types of the projection, how many types of the coordinates, local coordinates, UTM coordinates, and WGS84 coordinates, how we will write. And I have shared the details notes through to you. And after then we have seen the some basics features of the R, what how to make a vector file, list file, and this files to this one. And finally when we go to for the practical work, we have seen the how to make a beautiful map layout, and how to fetching the shape file, and how to convert this in a map file, and how this map file locate your point location, and how to add a ESRI driver through on this map layout we have seen. After then we are doing some raster analysis, and we are doing some point proximate analysis, and we have doing a stacking problem we have seen. So, and I think we have seen for this level plot we have seen. So this is the summary of the entire 5 days class. So now we are going to stop here. If you have any problem, please ask.
Hello, sir.
Yes,
Sir, thank you very much. It's really insightful and great presentation.
yes, thank you, thank
Sir,
you.
you given already the some codes for us. We tried by ourselves.
Mm-hmm.
So in future, if you want to do something new programming, how we can compile the code? Is there any shortcuts like from where we get the some codes, or
Yes,
we need to do?
yes, I will keep in touch with me. I will share my email ID to you. Okay, and please ask me, and I will share the books related to this book, and things, lots of things I will share through my email. So if anyone want, then please mail me. I will share too. Or anyone in problem, then please ask me. I will try to solve your problem. So keep in touch. I will explain things.
Yeah. Okay, sir. Thank you, sir.
Thank you so much, sir. Okay.
So, dear participants, uh, if you have any doubts, any clarification, you can ask
Sir,
through
is
chat
this
box
the
or
last?
unmuting your.
Excuse me, sir. Is this the last session?
Yes,
Tomorrow onwards?
yes, this
Okay,
is the
okay.
Yeah,
last.
yeah. Today is the last session, but not
Okay.
last session.
Yeah, yeah. Okay, sir. Then what about this e-certificate, sir?
Yeah,
Participation.
tomorrow by tomorrow afternoon you will get the e-certificates in delegates also group.
Sir,
Okay, sir.
Yeah,
excuse me, sir.
yeah, madam.
We were asking you to select a particular location and make us to work as a demonstration through our sirs. From the beginning, I was asking that.
Yes,
But,
yes, you are
Uh,
asking me in the beginning. I have already told you. Uh,
sir, one moment, sir. Actually, you have clearly explained the course, sir.
mhm.
But since it is a what the program we thought was, we will be given operation opportunity about the R package with your. Now you have given the codes, we are copying and pasting.
Hmm.
So now suddenly, if I select a location,
Hmm.
I'm going to have some difficulties and challenges in plotting the shape file, etc.
Yes.
So for that reason, I was asking to you from the beginning onwards, sir, you give the code, we will also open the R so that everyone will work, so that we also get the same output of a different location in this workshop. But it was missing, sir.
Sir, please try to do this. And if you got any error, then please take a screenshot of this and send to me. Because when you share with me your data, that's it, 2 points only for one coordinates, which I'm trying to plot on my R, but data is not a very prominent type. It's a data is not so good because lots of the feature with save. It's actually it's not a data. It's suppose that you are copy and paste it. When I'm trying to make this data frame for this, I'm facing the some difficulties. But data should be clean and things. Suppose that you are this thing. Suppose that you are from India in Delhi region, then must be written in the this coordinates of the Delhi region and India. Then I will definitely plot on this R. Suppose that that's the coordinates of the Zambia coordinates, and this what is the projection of this? What is the everything? I information is missing. Just select the point and send it. How can I define? If this coordinates is a local coordinates, then must be I have to data frame for the local coordinates. It must be if it is a UTM projection, then it must I have to give for the UTM projection for the Zambia. And I confuse with this data what type of the projection which win, because only one information is given with it. and that's why it's only a point without any information. And that's why we have to make a save file or vector file. We have, when we have a vector file, suppose that a save file, and you provide me a save file and then you provide me your data, then definitely I will plot this, because I know the information through your save file. I can extract all information, what type of the data is this, so I can plot. So you cannot simply plot a single plot on this platform, because lots of the files I have already opened in my R studio, and that's working in WGS84 through the UTM. And you suddenly send me the data, and I'm unable to plot on this because that projection is not matching with my R environment, which are for activated for the different type of the projection. So that's I'm facing the problem. But you trying to freshly trying to do select any, suppose that you are sharing my with me Zambia, then how to, I have already shared the all countries code for how to face this thing. If you know, please go to the this one which I have already shared, uh, country code for fetching save file. This is the country code, just put in this. AFG is for Afghanistan, and definitely you will get the for the Zambia, which I am going to share in a chat box and use for your country save file. And then through internet select that particular, because this save file is which when you will connect your GADM server, then this is in a WGS84, then your coordinate must be in the WGS84, then you have to convert this one. So I'm sharing this file with you. Just wait. I have shared this in WhatsApp group, and as well as in the chat box. Why I'm unable to return some anything in chat box, I don't know. I'm not operating this. So I have shared this. So do this for through um, R. If you're facing any problem, please ask. Hello? Anyone have any problem? Question related to this? Please ask.
Yeah, yeah. Dear participants, as the speaker said, rightly said, can clarify your doubts through chat box or unmuting your mics. I repeat, dear participants, the session is once again open for the discussion. You can clarify your doubts through chat box or unmuting your mics. You can ask questions
And
from day one
one
session to
one
till now.
requesting to all of you people. So I'm doing the live streaming this, but I'm here checking that no one is watching the live streaming. If at least people here have to watching this live streaming, because I'm everything's I have correct for this, like voice and visual effects I have corrected for this. So please ask, and everything is okay. Please say why write why in comment box, and I know, because recording has been started. Hello, hello, hello.
Yes, sir.
Yeah, yes, sir.
Yes,
Okay,
sir, everything is good.
okay, thank you.
Okay, sir. Shall we stop here?
So sir, sure.
Yeah. So, on behalf of File Analytics Institute and on behalf of all participants, we are very much thankful to our speaker, sir, resource person, sir, Seema Bakhtar, sir, for his very informative and very elaborate sessions. Thank you very much, sir.
Thank you, sir.
Thank you, sir.
Okay.
At the same time, on behalf of speaker, sir, and on behalf of File Analytics Institute, we are very much thankful to all participants for their active participation and active involvement. And with this, we'll stop here. Once again, we'll meet in some other online events. So tomorrow we are organizing one more 5 days FDP on data analysis using SPSS. You can participate and you can get benefited out of that. So once again, I thank speaker sir And once again, I thank all participants. So thank you, sir. Good night, sir.
Good night, sir. Thank you.
Good night, participants.
Okay, sir. Thank you, sir. Good night.
Good night. Thank you, sir. Good night, sir. Dear participants, by tomorrow afternoon, you will get all your e-certificates in Delegates WhatsApp group. Yeah. And soon after this session, we are going to share the feedback link in Delegates WhatsApp group. And fill the feedback link. And by tomorrow afternoon, you will get all e-certificates in Delegates WhatsApp group. Thank you.
Thank you,
Thank
sir.
you, sir. Thank you.
Thank you, sir. Good night, sir.
Good night. Good
Good
night
night.
to all of you. Thank
Good
you
night,
for
speaker, sir.
attending this session. Thank you.
Thank you, sir. Good night, sir.